Hello everyone, Ramya, Assistant Professor of CSC Department from Rohini College of Engineering and Technology, subject code CS3452, Theory of Computation, Unit 4, Topic, Normal Forms for Context-Free Grammar. Objectives: to understand the concepts of simplification of context-free grammar, to analyze the different normal forms for context-free grammar, to convert the grammar into Chomsky normal form and Graham-Bell normal form. Normal forms for context-free grammar. Various languages can effectively be represented by a context-free grammar. That means all the grammar are not always optimized. That means the grammar may consist of some extra symbols, that is non-terminals. Here the extra symbols is an unnecessary increase the length of grammar. Simplification of grammar means reduction of grammar by removing the useless symbol. Here we have some of the properties. First property is each variable, that is non-terminal, and each terminal of G appears in the derivation of some word in L. There should not be any production as x tends to y where x and y are non-terminal. If epsilon is not in the language, then there need not to be the production x tends to epsilon. Next we are going to see the different types in the reduced grammar. There are three types. First one is removal of useless symbol, elimination of epsilon production, removal of unit production. First we are going to see the removal of useless symbol. It can be useless if it does not appear on the right hand side of the production rule and does not take part in the derivation of any string. Here the variable can be useless if it does not take part in the derivation of any string. For example, consider one example. In this example, the variable C will never occur in the derivation of any string. So the production C tends to AD is the useless symbol. So we can eliminate the production rule C. Likewise, the production A tends to A is also useless symbol. There is no way to terminate it. If it never terminates means then it can never produce a string. So it is also a useless symbol. To remove the useless production A tends to AA, we will first find all the variables which will never lead to a terminal string such as variable A. So we can remove all the productions in which the variable B occurs. Next we are going to see the elimination of epsilon production. The production of type S tends to epsilon are called epsilon production. This type of productions can only be removed from the grammar. It does not generate epsilon. Here we have to follow some steps. Step 1, find out all the nullable non-terminal variable which derives epsilon. In the next step, for each production A tends to A, construct all production A tends to X where X is uptime from A by removing one or more non-terminal from step 1. The last step, we have to combine the result of step 2 with the original production and remove epsilon production. Now we are going to see one example for elimination of epsilon production. Remove the production from the following context-free grammar by preserving that. That means you are going to removing the epsilon production. We are deleting the rule x tends to epsilon and y tends to epsilon. To preserve the meaning of context-free grammar, we are actually placing epsilon at the right hand side whenever x and y have appeared. Let us take x tends to s, y, z. In this x tends to xy, if y for the y you are applying the epsilon, that y is removed. Likewise, each and every input string you have to do it. Then next we are going to see the removal of unit production. The unit productions are the production in which one non-terminal gives another non-terminal. Using the following steps, you are going to remove the unit production. In the step 1, you have to remove x tends to y, x tends to a to the grammar rule whenever y tends to a occurs in the grammar. Now delete x tends to y from the grammar. Repeat step 1 and 2 until all unit productions are removed. Now we are going to see one example for remove a unit production. For the given grammar, S tends to C is a unit production, but while removing S tends to C, we have to consider what C gives. So we can add a rule to S. Likewise, we have to do again and again. Finally, you will get one output. You have to rewrite that output. So it is called as a removal of unit production. Next, we are going to see the Chomsky normal form. It is the grammar, it will all productions rules satisfy one of the following conditions. Start symbol generating example, for example A tends to epsilon, a non-terminal generating two non-terminals, for example S tends to AB, a non-terminal generating a terminal, for example S tends to A. For example, you are going to consider two grammar G1 equal to G2. For that, first you are going to eliminate start symbol from the right hand side. from the right hand side. If the star symbol T is at the right hand side of any production, create a new production as. Likewise, in the step 2, in the grammar, remove the null, unit and useless productions. We can refer to the simplification of context-free grammar. In the step 3, in your right hand side of the production, you are going to remove the non-terminals or term. For example, production S tends to AA can be decomposed as S tends to RA, R tends to A. In this step 4, eliminate right hand side with more than two non-terminals. For example, S tends to ASB can be decomposed as S tends to RS, R tends to AS. Thank you.